Oh, and I need to make you a co-host. All right. Thank you for joining us this evening, or thank you to those of you who are watching this as a replay later. This evening, I have guests with me, team members from Lego Legion out of Cincinnati, Ohio. Hey, Lego Legion. They are a team that has always done exceptionally well in the project and are happy to share tips with your teams about how to approach the project and how to get started. We can talk at the end, if you'd like, about this year's innovation project specifically. The tips that Lego Legion has to share with you could be applied any season. But we'll go ahead and pass things over to Lego Legion to get started.
Hi, we're Lego Legion from Cincinnati. We're going to give you some advice about tackling the innovation project. I know it seems overwhelming, but don't worry, you can do it. First, a little bit about us. I'm Lucy. This is my 3rd year on Lego Legion.
I'm Alex. This is my 3rd year on Lego Legion.
I'm Peter, and this is also my 3rd year on Lego Legion.
Hi, I'm Noelle. I've done First Lego League for 5 years, and now I'm an alumni who's mentoring Lego Legion.
I'm Samuel, and I've done First Lego League for 5 years.
Hi, I'm Julie, and I did part of the outer space year, and I've been doing it ever since.
Our team mascot is Octavius the Chicken. He's a famous innovator himself. He made an appearance at the Global Innovation Awards this year. Lego Legion has been a team for 8 years. We are all homeschooled and range in age from 10 to 15. Most of us are younger siblings of Lego Legion alumni. We love the innovation project piece of First Lego League. We have some amazing opportunities, and we've talked to some pretty incredible people as we've pursued our innovative solutions. Several years ago, Lego Legion was the runner-up for the Global Innovation Awards. And over the years, the team has won project awards at state and international competitions. We've applied for a provisional patent, and we've worked with prototype developers, patent attorneys, industrial designers, engineers, professors, and so many other experts over the years. And along the way, we've gotten to create and build some pretty cool stuff. We've learned a lot about how to be innovators, and we are super excited to have a chance to share some of our experience with you. First of all, we want to show you a short video that helps to explain the engineering design process, which is the roadmap for how you will tackle the project challenge this year. It provides a structure so that your team can innovate in the same way that professionals do.
The engineering design process is a lot like making tacos. Here's how. Let's say you've had a long day. Maybe you've gone to class. Maybe you just got off work. Maybe you just finished an intense workout session. It's now 7 o'clock and you're hungry, but you've got friends coming over in half an hour. So what do? You go through the engineering design process. First, you define a problem or need. In this case, the problem is you're hungry and you've got people coming over in half an hour, and they might be hungry too. Next, you do some research to figure out the design requirements and your limitations. So in this case, you'd assess things like ingredients you have at hand, money you've got to spend, how much time you have before people start showing up, how many people you have to feed, and if any of those people have dietary restrictions. Once you've got a pretty solid list of criteria and constraints, you can start brainstorming ideas for solutions. Maybe you look online at nearby food options. Then, maybe you go to the fridge and you start figuring out what you can make. You weigh your options and you determine making something at home will be cheaper and faster than ordering something online. And you decide everyone likes PB&J, but you don't have gluten-free bread.
Oh.
But you do have corn tortillas.
I guess I'll try PB&J on corn tortillas.
And you make a prototype. You test out and take a bite. It's gross. But you want to make sure it's not just you, so you get others to test out, like your roommates or family. Everyone agrees, it's gross. You ask questions and determine what's gross about it. In this case, your testers like the tortillas, but not so much the PB&J. So you go back to the kitchen and reassess. This is what engineers call iterating, making changes based on test and user feedback. You realize,
I've got ingredients for tacos? Dope!
so you start making some veggie tacos. You try one and think,
This is kind of dry.
you have other people try it to get their feedback. Most people agree. It's kind of dry. So you go back to your kitchen and start iterating again. You find that you've got the ingredients to make guacamole. You make the guac and you add it to the tacos. You test it out and you're like,
This is tasting pretty good.
but some of the other testers think,
It could use some spice.
so you evaluate their feedback, you look in your kitchen, and you realize you don't have anything spicy. That's when you call your friend Sam, who's coming over. And you're like,
Hey Sam, can you bring over some hot sauce? I'm making tacos.
and Sam's like,
Sure,
also,
I love tacos.
it's now 7:30 and your friends start showing up. You tell your friends,
I made tacos if you're hungry. You can add hot sauce if you want.
and then you and your friends eat the tacos. They're like,
These are pretty good. I'm gonna Instagram that.
You should share the recipe online.
so you do. You've solved your hunger problem and engineered a taco party.
We hope you like that. Now we'll tell you how we implement the engineering design process when tackling the innovation project. Alex?
Picking a good problem is really important. Your first step will be to research the general topic, how to help people be more active. You can brainstorm general categories having to do with being more active. You can take field trips or talk to experts to learn more about ways people are active. You need to find a good problem that isn't too broad or too specific. You should be able to explain your problem simply and quickly. We often brainstorm a long list of problems and spend a lot of time talking through each item on the list. This is our brainstorm list from City Shaper. We look for a problem that is interesting to most of the team, and we spend a lot of time narrowing down our list. We typically avoid problems where there are always lots of solutions out there, although you can always improve an existing solution. We look for problems that can be solved with new technology. You want to condense your problem into one simple sentence, your problem statement. For example, here you can see our problem explanation, the statement for the trash truck here.
After you have defined your problem, your next step is researching and brainstorming a solution. Your team should throw out any and every solution that comes to mind and make a huge list of ideas. Use your experiences as a team and conversations you've had with experts to generate ideas. No solution idea is too small or too crazy during the solution brainstorming session. Then, go back through the list to see if any of them have merit pertaining to your topic. Talk through the pros and cons of each idea and decide as a team if you want to research deeper on those topics. As you research and develop your idea, don't forget to learn about what ideas are already on the market or in development. It's good to note products that are similar to your solution so that you can explain how your solution is different. Also, you can learn from existing solutions how to make your idea unique and better. If you find that your idea already exists, don't despair. Probably you haven't invented exactly the same thing. This is an opportunity, not a brick wall. Ask yourselves questions like, how is your invention different from the existing solution? Why did you design your invention that way? How did the differences make your solution better than the existing solutions? It's important to know your solution to the best of your ability, because the more you know about it, the better you can understand it and make changes. Consider all aspects of it. How it's designed, how it works, how it would be manufactured, and how much it would cost.
Once you have a clear solution, you'll want to design your product. Talk as a team about the best way to show your product. It might not be a physical prototype. You might choose to show a model or a drawing, even flowcharts or a computer model. It really depends on what your solution is. If your solution is some kind of system, like a computer app, you can design flowcharts or screenshots to help show how it would work. You could reach out for help or learn some programming to design the home screen or some representative pages. If your solution is something really technologically detailed or a large system, you could design detailed technical drawings or a scale model to show how your design would work on a large scale. If your invention is an actual product, our suggestion is to do some simple and fast prototypes to see how your design feels in real space. We worked with OXO engineers when we were designing our produce cleaner, and they said they make multiple prototypes as they design new kitchen utensils, just so they could see what each design feels like in their hands. You could design your prototypes out of simple cardboard and tape, and then talk about what you observe. For example, 2 years ago, we created our solution to scale out of a cardboard box, and we very quickly realized that the design wouldn't work in the space we had to work with. It looked okay on paper, but in real space, it was too big. We talk about 2 kinds of prototypes, and either might fit your solution better. A functional prototype works the way that your solution would work, but it may not look like much. A design prototype may not work at all, but it shows what your solution would look like. Choose the one that best communicates your solution. Julie?
Once you have a clear design or a prototype, you'll want to test your solution and share with people who might use it. For a while now, we've had a saying, fail fast, fail early. Whenever we create something, we want to know that it works, and we want to know quickly. Your first prototype should be simple and easy to build quickly. Build your solution and then see if it will work. You can be creative, and it doesn't have to look exactly like you imagine your final product. For example, our solution last year was a specialized streetlight. We built a quick and dirty prototype out of cardboard box and Christmas lights and proved that our concept would work. Another way you can test your solution is to research each individual element to see if it will work. For our streetlight, we looked at motion detecting lights, photography lights that change color, and streetlight systems that use sensors to dim and brighten lights as needed. If you find working technology for each element, you can likely prove that your design will work. If you can build a working prototype, you can collect actual data from tests using the scientific method. For example, we ordered petri dishes online one year and grew cultures from pond water. We often create charts and use them to show the data we collect. Another way to test your solution is to read through the rubrics. Does your solution pass the rubric standards? You can also collect data by sharing your solution with experts who would understand the problem and the concept of your solution. They will give you valuable feedback that you can use. You can also share your idea with the end user. That is, the people who would actually use the product. For example, we gave prototypes of our Animal Ally solution to local shelters, which used them with their animals and gave us feedback. Your team will need to create a 5-minute presentation. Make sure to stick to the rubrics and get as much information in as you can. You'll want to make sure you define the problem clearly and explain your solution as simply as possible. Peter?
The last step in the engineering design process is to iterate. To iterate basically means to refine and improve. So it is important to collect feedback every time you tell someone about your solution. Consider the suggestions and discuss how your team could implement them in the design or function of your solution. One thing we've done is found experts in prototype design to help us with this process. Also, keep learning about new technology because you might find a piece of technology that could help improve your solution. For example, during Into Orbit, we were developing a solution to block radiation so that astronauts could be safer in space. As we researched, we learned about a brand new material called BNNT, which is very lightweight and compact. That discovery allowed us to develop our final solution. Each new iteration basically starts you back at the beginning of the engineering design process, which is why it's often shown as a circle. As you test and share, you evaluate your design and improve it. Then you go back to prototyping and share and test again. Each circle around the engineering design process is a new iteration. Also, make sure to record and document each iteration so that you can remember what you've done and the process you went through to arrive at your solution. Incorporate your documentation into your presentation. You see?
Like Peter said, you will continue to design, share, and improve throughout the season. Make sure you have fun exploring ideas and connecting with professionals. Think of new ways to better explain your solution and how great it is. If you get stuck or have a question or need advice, please feel free to reach out to us via email. You can also check out our website with some of our innovation solutions over the years. Thanks for listening. Do you have any questions?
We have a pretty small group. If anybody has a question, if you want to ask over your microphone, or you can type any questions that you might have in the group chat as well. Nice job. I agree. They did a very nice job. I love that video. I wish I had access to that video back when I was coaching my 4th and 5th graders. There's a question from Gyro Lions. Or did I mute you? You're unmuted if you want to talk. Or maybe not. Okay. Well, if there are not questions, I will join everybody. Oh, it says the microphone won't work. Okay. Typing her question. How do you enroll all kids in the process? So how do you keep all of your team members engaged in the process? It is okay for the coach to answer this question as well.
Go ahead. The coach is off screen motioning at them to answer. Go ahead. How do you make sure everybody knows about the project and is involved in it? What do you all do having to do with the project?
While they're thinking, I will say, I think it's very important for the kids to have ownership in the process and to actually be researching a topic that they are interested in. When kids are interested in a topic, they want to learn more about it, and that happens more organically, and they're more self-motivated to do so. It doesn't usually go very well when the coaches try to pick the topic or force a topic on the team. So I would absolutely encourage you to do what LEGO Legion laid out with brainstorming sessions and making sure that the kids choose the project. That's a big deal that I've seen from my perspective as both a coach and the partner.
Yes, I would agree with that. I think that a way to get everyone involved is at the beginning when you're brainstorming. Everyone can put in ideas. When you're researching something more specific, everyone could go on a field trip. If the team is more split up in project and robot as separate groups, we often do group meetings at the end of each meeting, telling about what we got done and just informing everyone of the steps we've taken in the project.
LEGO Legion, do you all specialize on your team into special roles?
Yes, we pretty much do.
Well, we all do a mix of everything. Like I do robot and project, just at different times.
This is our smallest team yet, and Noelle is not actually going to be on the team this year, and this is the first year that every single kid on the team is interested in robots. So we're pretty excited that we're going to have, we may have everybody doing both this year, but normally we do kind of specialize. I would also add that it seems like everybody is involved in the discussion about picking the project and picking the solution. And then it seems like as you get into the season and you develop the solution and you're developing that while the robot team is busy at work, I feel like most years we sort of pull apart at that point. But then we all come back together once we start rehearsing the presentation, and we kind of, that presentation, it seems like catches kids up to speed who maybe have been more involved with robot for a while. And then just having to be in there and learn those lines and start putting the presentation together, it seems like that will pull kids kind of back together on both the robot and the project.
Right. It is very important that everybody on the team is involved in all aspects of the program, but many teams, especially larger teams, do specialize to where people are primarily focused on project or primarily focused on robot, but they also contribute and learn both parts. When my daughter was on a team, she was all project, but she would work on programming for a mission. It was never actually successful, and they actually brought that into a humorous aspect of their presentation. But she did learn programming. She learned a lot of what didn't work, which actually helped her learn much more about programming than she ever realized. We have another question. We are a new rookie team. Can you walk us through what this looks like from a team perspective, as in working on it at meetings, meeting with an expert, etc.? So this is going to be an interesting season for meeting with an expert. I think in some ways it might actually be easier to meet with people because everyone's getting so accustomed to these Zoom type meetings, right? So it might actually be easier to connect with somebody. How do you all divide it? Do you do all of your work at practices? Do you do some of it as homework? How do you divide it, Lego Legion?
Well, I know we do most of the robot work and actual meetings because we have the actual resources to build and program.
Mm-hmm.
But we do a lot more project. We have a bunch more homework doing project. And then we do some more work. We're just doing a lot of work at the meetings, and then depending on what is needed, we'll assign homework then too.
And when you're meeting with experts, do you call it a field trip?
Usually depends on the situation.
Depends on the situation.
We kind of categorize our field trips as like research field trips and then sharing with experts. So like, I don't know what we'll do this year, but normally at the beginning of the season, we'll come up with 3 or 4 things that just generally have to do with the topic, and we'll go on, a field trip somewhere. Like we went to visit a dam at the beginning of hydrodynamics. It ended up not having anything to do with our solution, but it was just learning about water and learning about, you just never know where that problem and that solution are going to come from. And so it's good to just get kind of a general overview of knowledge of the topic. And we all go on those. And then we do a lot of phone calling to experts. Sometimes we go meet with experts. It just depends on where they are and how easy it is to access them in person. If we can meet in person, we go with at least some of the team. Maybe it's not everybody, but we do try to meet in person when we can. And like you said, Brenda, this year might be different.
Right. How often do you all meet?
We usually meet on Wednesdays and Saturdays, and probably about the week before our tournament, we meet a bunch more.
That's my experience as a coach too. We would meet once or twice a week until it was 1 or 2 weeks before the tournaments, and then it was like game on. All right. So there's a question that it doesn't seem to be coming to the whole group. As I understand it, there's a project, you need to display info about the project, you meet with an expert, what else goes into the project, do you need to make a model? That's a great bunch of questions, and especially asking about the need to make a model, because in all previous seasons, that was not necessary. It was extra, and the judges would get all excited and talk about the teams that made a prototype because it was only a handful of teams. But this year it is actually on the rubric. So I would encourage you to look at the official rubrics, which I'm going to post a link here in the chat for everybody. The rubrics are available on the, oh, I didn't send it to everybody. Hold on a second. The rubrics are available on the web page at first that talks about the challenge, where the videos and everything were published on the first day. And there's a rubric. Let's see if I can share my screen. All right, so I'm trying to pull up the project rubric here. Can everybody see the project rubric? This is new this year, so as you're talking with more experienced teams, everyone's getting used to a very different rubric than what we've experienced before. And it has these criteria, which you'll recognize some of them from LEGO Legion's presentation about the engineering design process, that the team needs to identify a problem. So that's the first thing, is identify a problem that you want to solve. So this season, that's a problem about people not being active enough. Identify a problem that you want to solve, research the problem, and then you're going to design a solution to that problem and create, this is new this year, team developed an original idea or built on an existing one. That's not new, that's always been there, with a prototype, model, or drawing to represent their solution. So I do want to point out that it does say drawing. If a team is creating an app or something along those lines, a flow chart like what the LEGO Legion team shared would be a good idea. They don't necessarily have to create the app, although they might. Don't hold them back if they can. It is okay to work with somebody else to help get that developed. The kids have the ideas, the kids know how it's supposed to work, and there's a college student who knows how to make an app. How cool if they work together to make the app. So a working prototype is great. Something built out of cardboard is great. A lot of teams, if they can build something out of Lego, they build something out of Lego. So whatever you choose to make, you're representing it to the judges. It doesn't necessarily have to be a working prototype. And then the team's going to iterate, share their ideas, collect feedback, make changes, and then present at the tournament. So I would use this rubric with the team, make sure they know this is how you're going to be evaluated. These are the goals. So it really breaks down to identify a problem, solve it, create a model or a prototype, and then iterate and share. But I would absolutely recommend using this as a planning tool for that. Let's see if I can get back. Any more questions for us or for the team? Where do we find the project topics? In which handbook? So we used to get a lot more from FIRST with regard to the project. In the engineering notebook, there's a page that has like the steps I just went over laid out, not with the rubric attached. Identify a problem, design a solution, create your prototype. And it just says, identify a problem associated with people not being active enough. And then it says, design a technology solution to solve that problem. I'm surprised that they included the word technology there. And I do want to say that in Ohio, any tool or anything that you use to solve the problem, we're going to consider technology. An awareness campaign would not be a technology solution. I think that's what they were trying to avoid. Last year, FIRST did publish a blog post that was very rich with information about the project, and I'm hoping they do the same this year. It matched what used to be available to us, but I haven't seen that yet. The topic really is simply identify a problem with people not being active enough and solve it. Did that help? Okay, good. All right. Last call for questions. Did anything else pop in your heads that you wanted to share? Are you good? We're good? All right. Oh, we have one last question. All right. Thank you. Thank you for joining us. Yes, this could, so the question is, this could be to solve a problem or address a cause of inactivity. Yes, absolutely. Yeah. All right. People are starting to drop off. I'm going to end the recording.